finishing up Unit 6. So a few more lessons. Good news, 6-6, 1 day, no free lesson. So this is just kind of be a little different, but not very different. It's very similar to what you've been learning. So I think we can just knock out quite a few examples, and then you'll be ready for your homework. So let's get into the basics. Common bases, happy places. If a problem's written like this, there's no reason to slap a log on both sides, because I can just look at this and go, hey, x equals 7. It has to be. Because if I put a 7 in there, how can that not be true? Okay, don't you wish they were all like that? This is algebra 2. So it's going to push it, make you work to get to here. And here it is. So, but we've done these before. Here's a 4. Here's a 2. Which one's bigger? It's a 4. Can you turn that 4 into a 2? By golly, you can. That's 2 squared. Now, what if that 2's down there? Well, I need that up so that I have this looking thing. Well, there's an invisible power of a 1, so if I bring it up, that'd be -1. The x plus 7 equals 2 squared to the 3x. Now you got to remember your basics. When you raise a power to a power, what do you do to these powers? You multiply. So I get 2, -x minus 7 equals 2 multiplied to the 6x. Remember, when these bases are the same, this has to be the same as this. -x minus 7 has to equal 6x. I'm going to add x. It's just a simple math problem now. So -7 equals 7x. Divide by 7, divide by 7. X is -1. So there's your little math trickeration. Every problem is going to be a little different, so don't stop this video. There's different stuff coming. Okay, here we go. Before we even solve these, I want you to notice the difference. Okay, here's a 3 and a 5. They don't seem to work together too well. Here's a 25 and a 125. We're going to be able to manipulate these pretty good, but for the first time, I think, this trimester, something unique is going to happen. Normally, you can take the big one and write it as a power of the smaller one. Now let's experiment. 25 to the first is not 125. 25 to the second is 625. So I can't use 25 as my common base. Not going to work. So what's my common base going to be? A 5. Because I can say 25 equals 5 squared. And I can say 125 equals 5 cubed. So that's what I'm going to use for substitution. So I'm going to write this as 5 squared to the 3x. I'm going to use 5 cubed to the 125. You can see how this is similar to the other example, 2. Now I have a power to a power, so I multiply. Power to a power, but you got to multiply both things, so I get 5 to the 3x plus 6. The 5's just disappear. I know that that power has to equal the other power once I get common bases. Now math should be pretty easy. So 3x equals 6, divide by 3, x is 2. Then, for the first time on this lesson, we look at this and we're like, whoa, a 3 and a 5, there's just no way. And to our rescue comes the logs. So we're going to just slap a log on here. We'll move that over here, slap a log on here. There's no way common bases, happy places is going to happen using this technique. But notice what we just did. We did just give it common bases. I don't know if you've thought about that before, but now it's solvable, but a little bit more work, and we're definitely going to need a calculator for this one, so let me grab that little thing. So what do we do with this? Well, we bring it in the front. So x plus 1 times log of 3, I think is 0.477, because we've been doing that a lot. And I'm going to do the same thing here. Bring the x in front. X times, now I don't have log of 5 memorized. Here we go, log of 5.698. Now just so I don't screw this up, I want to double check, see if my memory is, yeah, 0.477. Okay. So So I distribute, 0.477x plus 0.477 equals 0.698x. Just weird looking, but 477x gone, subtract 0.477x. So I get 0.477 equals 1, 2, 2, boom. So that worked out nice. Now I divide by 0.221, gone, divide by 0.221, whatever I get is my answer, 0.477 divided by 0.221. 2.16 approximately. Okay, who knew? All right, let's get after some more examples. So I'm not sure I needed to do this example because it's really similar to the previous one, but maybe just to kind of help you see the repetitiveness of this. So I have a 2 and a 7. There's just no way I can write 7 as 2 squared, 2 cubed. Not going to happen. This is where you got to slap a log on, and then you bring that in the front. So I get 3x times the log of 2, which I'll just look up right now, but we remember that's 0.301. And then I got to bring that power in the front, so it's x plus 1. Notice it's more than one thing, so I'm going to put parentheses around it. Now I'm going to figure out what log of 7 is. Log of 7, enter 0.845. So lots of decimals. So this would just be 0.903x equals, distribute, 0.845x plus 0.845. Subtract 0.845x, subtract 0.845x, and what would that be? 55, 58. So 0.058x is 0.845. Well, that's easy to make a little mistake there. Divide by 0.058, gone. Divide by 0.058, here we go. Divided by 0.058, 14.57. Okay, next few problems are going to be slightly different, so don't stop this video. So the author on your homework is going to give you a few of these and just say, hey, rewrite using logarithms. So they're not telling you to solve for x, so just pay attention to the instructions. So really all they're saying is slap a log on there, slap a log on there, and let me make sure I find out where they exactly want us to go. So I just double checked. There's nothing on your homework that's anything like these. So we just say we're good. I think so, but that would be it. Okay, now maybe they bring the x in the front. We've been doing quite a bit of that. So there's nothing on your homework like that. Okay, so a few more problems, slightly different. Okay, so if you can look at this one and just go, you know what? I know x is 7. You're using basic logic. Now look at this. The natural log of this crazy looking thing is equal to the natural log of this crazy looking thing. Well, just like this exponent has to equal that exponent, this stuff has to equal that stuff. Just has to. And now the whole world of logarithms are gone. So now I got to just treat it like a good old trinomial. X squared minus 6x minus 16 is 0. And I'm going to factor that. So I get x minus 8, x plus 2. Then I get x is 8 or negative 2. Now there is a twist in this stuff. And here it is. Remember, if I had like a log, and like I'll just put a negative 10 here. I say, hey, what's the answer? If you type that in your calculator, it's going to be error. Why? Well, 10 raised to some power will never give me a negative. So I can never have a negative in that spot, and I can never have a negative in this spot. So I got to check my answers for this, and that's why this stuff gets a little dicey. But if I put that 8 in there, I get 8 squared, 64 minus 16. If I put 8 there, I get 48. So that's no problem, because there's positives in there. What about this -2? Well, if I look at this -2 and I put it in there, I get natural log of -12. Can't have a negative in that position ever, so that kicks it to the curve. That's a little curveball. Look out for those. Similar to the last problem, now you got the regular log with a base 5, and then this stuff. What that means is the stuff has to equal the stuff. So subtract 4x, subtract 4x. The world of trinomials comes back. 2 factors of 45, -45, and add to -4, -9, +5. So my possible answers are 9 or -5. Don't just move on to the next problem, patting yourself on the back. If I put that 9 in here, that'd be positive. If I put that 9 in here, it'd be 81 minus 45, positive. So that's good. If I put that negative right here, I'd get a -20 in there. Not possible. Can't happen. Last type of problem they're going to hit you with in this section. It's just a whole bunch of craziness. Okay? But it says solve by graphing. You see, there's no way I'm going to take this binomial, multiply it by itself 5 times, and actually be able to figure that out. So this is where we go to decimals. So I'll see you in 2 seconds over by my computer. Okay, so what you see is I've typed in the left-hand side of the equation that I just had up on the board, quantity 2x plus 1 to the 5th power, and I graphed it. So I graphed the left-hand side of the original equation on the board right there. Now I'm going to type in the easier side, which is just x minus 2. And all you have to do is hold your cursor right over there, and there's your answer, -1.128, comma, -3.128. So we just set them both equal to y, graph them, and where they intersect is their, that's what technically, remember the problem is asking for x, so they're not asking for the coordinate point, they're asking us what's x. So our x would be the first one, -1.128. So that's how you think your way through that. That's it, guys. So if they give you some crazy things on both sides of the equation, this is your go-to. All right, have fun on your homework.